we can use a command like this. Net, where we just omit this part. Net equals to train net, the sample point x and y. So we can establish the neural network. We can train the neural network by a command like this. Train NDT x and y. So we can easily train the neural network. And later we can use the neural network. So our question is, after you have trained the neural network, what are the weightings? The weightings are selected to minimize the training error between the actual output and the simulated output from the neural network. So we have to determine the weightings. How can we find the weightings? If we want to display net, we will say that net is an object. There are certain components, membership functions or membership components in the object. So where are the weightings? The weightings should be specified by AW and LW. AW for the input weighting and LW for the output weighting. So we can display the weightings like this. Net.AW. And AW has two cells. So we can display the first cell like this. So these are the weightings for the first layer.
For inside the square, every W1, for example, Y, you want to represent a complete system.
Yes, the system is described later. If you train the system, you will have W's and V's. Later, you can use W and V's only
So
you have to generate
5 systems.
Yes?
We have 5.
Yes. No, 5 nodes. One node is a neuron. Is one neuron. For a neuron, we have weightings and the threshold.
So like output, for example, for the first one,
Yes.
circle,
Yes.
inside the circle is a transfer function, or what we have inside the node.
It contains a transfer function as well. Apart from the weighting, it contains transfer function. However, the transfer function is defined already because when I establish the neural network, I have defined that it is a log signal and function already.
So the log signal is inside the node.
Yes, it is. So you can consider the node as a neuron, which has the weightings as well as the transfer function, and the mass speed, the threshold speed.
You say you write just 2 log signals.
Yeah, you can change them. You can, for instance, you can use 10 or something of your own for the function.
So why 2? No, 5.
Because there are only one layer, two layers. I mean, this one is for the first layer, not for the first one, for the first layer. Everything of the first layer. I'm not sure. I don't think we can select transfer function individually for the different nodes. We have to talk about the whole layer. So in this case, we can train the neural network so that we can find the weightings. And similarly, we can display V's. And in this case, we can establish a neural network. And the next important step is how can we validate it. For this particular example, because we are trying to fit the curve, we do not have to separate we do not have to divide the original samples into two groups. It is not necessary. What we need to do is to use an X vector. A new X vector, we call it X node, equals to 0. So we can have 1,000 points in this case. And we can now use theme command. Since the next variable here is the neural network we have already obtained, we can use it to calculate the y values, and then we can display the values of y on top of the sample point. Oh, now this is not train, not well trained. Well, that could be something wrong with the new version. This is a neural network toolbox changed a lot. So some of the functions in the new version may not work. So we have to go back to the old version for the same example. And in the example, what we need to do is to generate the sample points first. And then we can define the neural network again. And then we can train the neural network again. I'll just use net equals to train net x and y. Y1 equals to theme net x0 so problems.
Why not we take a short break while we figure out this?
I think something wrong with the version.
So let's take 5 minutes break.
Okay.
While Professor Xue try to figure it out.
I think 5 minutes break version problem.
Coming back, I have an announcement at 2 o'clock. Our ECE will send a person here and to do a course evaluation. Please stay here at 2. He will be here sharp at 2. So, Professor Xue, can you